Jim Rush with Trenchless Technology Magazine. I'm here with Alex Margevicius with Cleveland Water. We're here to talk about the Ferncliffe Avenue relining job. First of all, Alex, can you tell us a little bit about the background of the project, why that was identified for the renewal?
We do water main renewal in a couple of ways. If a water main is structurally sound on the outside but has suffered from internal tuberculation, we've historically used the cleaning and lining process where we clean it and then put a cement mortar lining on the inside. But that's not a structural solution. If a water main has an excessive break rate, we look for a different solution that gives us structural integrity. Traditionally, that has involved main replacement, but we were looking for something new, and we were looking for a candidate. We looked for a street that had a high break rate, and we also wanted to go in a street that really wasn't extremely heavily industrial or commercial. A residential area seemed to strike us as a better first candidate to pilot this technology. We were also in the neighborhood doing some other work, so this seemed, Ferncliffe Avenue popped up as a good candidate, as a main warranting some structural work.
Okay, as far as the process you selected, can you tell us a little bit about that and what you found favorable about it to go ahead and pilot it?
Well, we've been looking for some time for alternates to simple open trench main replacement. Open trench is extremely painful to residents, to customers out there, to the commuting traffic out there. You've got a 6-foot wide trench, you got dirt everywhere. It's messy, it's inconvenient. We wanted to try and find something else. Water main is a little bit different perhaps than some other underground utilities in that you have service connections up at a 45-degree angle, the corporations protruding into the pipe a little bit. There have been attempts in the past at various liners, but there really hasn't been a good solution that we've seen yet to accommodate all the issues and challenges that come with smaller diameter main renewal. Until this product came along with Senexin, we invited their representatives to come in, we saw their presentations, and we thought there was good promise to this one, so we decided to go ahead and pilot this street.
Okay, can you tell us a little bit about some of the initial results, what you found so far with observing the pilot?
Well, clearly some of the major advantages that we liked being without the open trench. You go on site now and it is a much cleaner situation out there. There is temporary bypass, but you'd likely get that anywhere with a main replacement project. But you have a hole only every 500 feet. Traffic is much more easy to get in and out. Residents are far less inconvenienced. Street is much cleaner than it otherwise would be. So from that point of view, from those types of logistics, the project has been successful. There's a whole battery of tests that will be performed after the lining is complete. We will be doing hydrostatic testing as such, so those are results that we're still waiting to get. But initial results, we like what we see so far. We have witnessed the liner going in. It appears to be going in well. Process seems to be well tested. Apparently it's a process that have been used a lot in Canada so far.
Okay. How did the whole process come about? I know that as far as the water main lining, trenchless water main lining has been a little bit slower than the sewer side, and just what was the reaction of some of the people with trying some new technology?
I don't think there's been too much resistance here. We have used structural lining. We've used carbon fiber lining, for example, on a large diameter pre-stressed concrete pipe recently. So we're always looking here, I think. The water industry in general, I think, is a little bit more staid and conservative, perhaps somewhat. But one of the barriers has also been the fact that we're delivering potable water. It's got to be drinkable. And not every product that is used, say, on the sewer side is rated for potable purposes as well. So that's another hurdle and perhaps another reason why there haven't been quite as many products coming along on the drinking water side.
Okay. As far as the next steps, assuming the post-testing and everything goes well, I mean, how do you see something like this being used at Cleveland Water going forward?
Well, I think there is some concern a little bit about price. It is a little bit more expensive than water main replacement. Not hugely so, but maybe a 20% or 30% premium, it appears right now. So I think we're going to have to weigh that. I think we have great hope that in the future, as perhaps the technology becomes more used in the U.S., and contractors become more familiar and comfortable with it, that the price will come down and become more cost competitive with straight main replacement. And we perhaps may take the approach of perhaps bidding some jobs with alternates, with straight main replacement and with this technology. And maybe if they can end up competing, they can just win it straight up.
Okay. Well, anything learned from the project so far that you weren't aware of before the pilot started?
Well, the contractor has had a few minor glitches with some hardware and some equipment. I think that's to be expected. Nothing, I mean, any kind of newer technology, there's going to be glitches and problems to work through. Though I think, as big a conclusion as any is surprisingly how trouble-free it has been, I would say. They've basically been able to come in as planned, and the lining has essentially gone in very well. So we like what we see so far.
Okay. Well, thanks a lot. And well, I guess that's it, huh?